Thanks, students. In the previous video session, you have gone through the impulse and some of the examples about the impulse, and let us discuss about this friction. And this is your new topic. Maybe you have learned your smaller grade and all about the friction. And today we can discuss about this friction and the types of the friction. You know this thing here. You can see the diagram. Here you can see one object is at a rest on this table. So you know that if it is a rest, it is not moving, and assume that you are applying an external force on this object, a small gentle force you have applied on this, but even it is at a rest, it is not moving, it does not move. So why this object is not moving? That is what you see. One object is on the table at a rest position. You have applied a gentle force. Gentle force means a small force you applied on this, but this object is not moving. For example, you see here. Here one object is there, one book is there. I am applying a small force like this. Small force. Small force I am applying on this book. Now it is not moving. It is staying at rest. Why? Because what is the reason? The reason behind this is friction. This is because of the friction, the object it is not moving, and when I am applying a gentle force on it, there is an equal and opposite force which is acted on that. That's what that object is not moving. Because of the opposing force exerted by the surface on this object, and it resists the motion. The object is on the table. I am applying a small force on this. It is not moving. Still it is at rest, means opposite direction. What is there? You see the opposite direction. The same force. For example, I applied with a 10 Newton force, means the opposite also it is acting the 10 Newton force on this object from the surface, and this force is resisting the motion. So that is what we can tell that friction or frictional force. So this frictional force is always opposing the relative motion of an object and the surface where it is placed. Always this frictional force will be opposite to the force which is applied. You are applying the force in this direction, opposite to frictional force will be there. Any direction you are applying the force on the object, opposite direction, there must be friction or frictional force will be there. That is what sometimes we are pushing the table very hardly also, some heavy object and all, we are pushing what? It is very difficult to push and move that object because how much heavy it is, that much of high force we are applying on that object. Oppositely you can see the same high force is acting from the surface. That's what we are feeling sometimes to push the object on the ground because of the frictional force. That's what this thing. Some of the place to reduce the friction and all, we use smooth surface and all, so that easily we can move the object. So this is and all we will discuss later. I am not telling about how to reduce friction and all. So this is what so friction means, or the frictional force means what it always opposes the relative motion between the object and the surface where it is placed. It is a opposing force. So we know that what is this relative motion. Assume that you are applying the force parallel to the surface on the object. That force is trying to move the object. You see here I applied a force on this object. That force is trying to move the object. That is what relative motion. And this relative motion is opposed by what? The frictional force. And remember this thing, frictional force is also always opposite to this applied force. And mainly there are two kinds of friction which is called, we can tell that static friction and kinetic friction. Let us discuss about the static friction and kinetic friction. This is what the static friction. What is this static friction?
Static friction means, assume that
here I told I applied a force on this object, or you can, I will show you the example. Here is the object. I am trying to applying a force on this object. Now you see, even when I applied a force on this object, it is staying at rest. It is staying at rest. So some force which opposes the initiation of this object. Some force is opposing from the initiation of this motion of the object. It is not moving. Some initial motion is opposing by some force. That's what it is at rest. And that opposing force we can tell that static friction. So the static friction means it is the force which opposes the initiation of the motion of an object on that surface. So maybe you have understand. Again I will tell you. You see here one object is at rest and I am applying the force on it. This object is not moving. It is staying at rest. We know that whenever when an object is at rest, there will be a downward force, gravitational force acting on this object. To balance this gravitational force, there must be some normal force also acting, which is upward. So gravitational force is acting downward, normal force is acting upward. This is making the object to stay at rest. When you are applying the force, what is happening? What is happening? Some force is opposing this motion. Some force is opposing the initiation of the motion of this object, and that force we are saying static friction when an object is at rest. So you say that now you see that this is a thing. So static friction means what? So it is a force which opposes the initiation of the object on the surface. So before saying that, I said that even when an object is at rest, it will continue to stay at rest because of the forces acting on it. What are the forces acting on it? The downward gravitational force and upward normal force. And what is happening? So that is downward force and the upward force is same. So the resultant force will be zero. We know that as a result of this object will stay at rest. Assume that you are applying some object, applying some external force parallel to the surface when the object is at rest. So that what will happen? So when we are applying the external force on this object, from opposite direction, what equal and some equal force is acting in the opposite direction. That is what we are saying friction. And this one will trying to keep this object at a rest. And this time we can tell that external force applied and the frictional force acting, which is in the opposite direction, both will be in water. Same. So there is no motion happening in the parallel direction. It is staying at rest. So if you want to move this object, what do we have to do? We have to increase the external force. When we are increasing the external force, we know that this object will start to slide. When we are increasing the external force on this object, the object start to slide. Now what is happening? The magnitude of this frictional force, now here some frictional force is acting, and that one magnitude of the frictional force is what? Now more than this applied force. Sorry, the magnitude of this static frictional force is less than the applied external force. That's what the object start to slide. So there will be a condition given for this static friction. It is a short answer question. So that you see 0 less than or equal to Fs less than or equal to mu(s) ns. Actually, what is this mu(s) means? We can tell that the coefficient of friction. This is a condition. So 0 less than or equal to Fs less than or equal to mu s n. So n means normal force, mu s means the coefficient of static friction. This coefficient of static friction means nothing. It is just showing the relationship between this frictional force and the normal force. Just to show the relationship between the frictional force and the normal force, we are using a constant so mu s, coefficient of static friction, and the condition is 0 less than or greater than Fs. So the static friction will be greater than what? 0, but it is less than or equal to the normal force. That's what I said. When you are increasing the external force, the object start to slide. When the object is start to slide, now the static friction is less than what? 0. Sorry, greater than 0. Greater than or equal to 0. But now the static friction is what? It is less than this normal force. So to make this relation only, they are using this mu s, coefficient of friction. And this is a condition for static friction. And remember this one, this is a short answer, question number 8. So what will happen? The static frictional force is always greater than 0. When an object is start to slide, it's static. If it is start to slide, what will happen? The static friction will be greater than the 0, but it is less than what? The normal force. That is a condition. And based on this, we can tell that assume that one object is at rest, there is no external force is acting on the object. Then what will be the static friction on the object? Assume that this object is at rest now. Now this object is at rest, there is no external force act on this object. Now the static friction acting on this object also will be 0. Because the object is at rest. Assume that now the object is at rest, there is an applied force, a force is applied to this object. Now the static friction acting on this object is exactly equal to the applied force, but the static friction is still less than the normal force. So two conditions I said. The first condition is what? When this object is at rest, it is what? Staying at rest. Now the static friction is 0. Second thing I said, the object is at rest, but I applied a external force on this object. When I am applying the external force on this object, now the static friction is what? Static friction is greater than 0, but what? It is still less than what? The normal force. And once the object start to slide, what is happening? When the object start to slide, assume that the object start to slide. Now the frictional force, the static friction acting on this will be maximum, we can tell. Assume that the last condition, now this is a book, I am keeping one object here, and above this I am keeping another object. Above this book I kept another object. Now I am applying the force. We know that it will be difficult. It is so hard to move this object because now you see it is what? Pressed downward. Now it is pressed downward means the normal force acting on this object also will increase. So when it is pressed downward, the gravitational force acting on it, so that the normal force is acting on it also increasing. When the normal force is increasing, it is more difficult to move this object apart from this normal force. So these are the things we can tell about the static friction. And so static friction means the force which opposes the initiation of motion of an object on the surface. And kinetic friction means, suppose you are applying external force on this object. Sometimes we know that in the class and all, the teacher will ask you to move the desk and the bench. Suddenly you will go and you will pull or push the desk, so that you can see that one bad sound will produce from that desk. And that time when the desk is moving, one bad sound also you can hear. And you can see that the desk or bench you are moving, it start to slide, and that is what we are saying. That time there is an opposing force which is acting on the desk. That is what we are saying, kinetic friction. So if the external force acting on the object is greater than the maximum static friction, then the object starts to slide. So when the object slide, the surface is exerting some frictional force. That is what we are saying, kinetic friction. So during this time we can tell that kinetic friction is, there is a condition, kinetic friction will be equal to what? The normal force exerted by the surface. And here we are using the mu k, and here it is coefficient of kinetic friction. To connect these two relation only we are using. And now there is a 3-mark question. So what are the differences between static friction and kinetic friction? You can see here static friction or starting friction, you can tell kinetic friction. So static friction you can tell, starting friction you can tell, then kinetic friction you can tell, sliding friction you can tell, or dynamic friction also you can use. So static friction means, first difference is the salient features of static and kinetic friction. This is one of the important 3-mark question. You can learn this table. So static friction, it opposes the starting of motion, and here it is opposes the relative motion of the object with respect to the surface. This is what already I told, I explained all these things. And the static friction is always independent of the surface area of conductor. The same also kinetic friction also independent of surface area of conductor. And this coefficient of static friction depend upon the nature of materials. This is depending upon, kinetic friction is depending upon the temperature, nature of the materials, and as well as the temperature. If the temperature is increasing, what will happen means the friction will get a decrease. That is what it is depending upon the temperature and the nature of the materials. Actually, if you are using a rough surface, on the rough surface you are pulling the desk, and tail surface you are pulling the desk. Which one will we feel easy? Yeah, we are feeling. Then the object fastly, which one will start to slide? The desk which is on the tails will move first. That is what it depend upon the nature of the materials and the temperature. Next one is depending upon the magnitude of the applied force. And you see here the static friction is depending upon the magnitude of applied force, and kinetic friction, it is independent of the magnitude of applied force. And last one is the condition. Here static friction is maximum is greater than kinetic friction, mu s is greater than mu k, so that so here kinetic friction never be 0, and it is less than the maximum value. Coefficient of kinetic friction is less than the coefficient of static friction. So these are the difference, and I said that many things about the static friction and the kinetic friction. So remember this thing, one object is at rest. If it is opposing, the opposing force is acting on the object is resisting the motion of the object. That is what static friction. And kinetic friction means once the object start to slide, then some force, because you know that once the object start to slide also, we know that after some time it stops, because now what is happening? Now also, when there is a kinetic friction also, when there is object start to slide also, there is some opposite force is acting. That opposite force only we are saying kinetic friction. Okay, so all of you go through this, and it is one of the very important 3-mark question from this part, and this is one of the very important 2-mark question, this condition for static friction. This short answer, question number 8. So you can go through this and watch this video. If you have any doubt, we can discuss in the Zoom session. Thank you all.